Alright, guys. So we are going to do this question summarization. You have given an array of integers, right? And your task is to count the number of subarrays having sub x, right? And constraints are interesting here, guys. You see, constraints are like n is like number of elements will be positive, but target and this value of this could be negative also. That is the one important part of this question. Right? These could be negative. So how will you solve this, right? When you encounter the negative input is like this is 2 minus 1 3 5 minus 2. So let's say the input is here like this. 5 comma 7 are the 5 is the number of let's say this is n is equal to 5 and target is given 7, right? Now the array here we have given is this 2 minus 1 3 5 minus 2, 2 minus 1 3 5 and minus 2. We have given this array, right? Now we have to find the target 7 when we get the subarray sum as negative or like target equal to that. So one thing we find was we can do that left comma right, right? We can have two pointers. This is left, this is right, right? Here subarray sum is what? 2. Then I encounter R, right? Then it is R is here. Now it is 1. Then it's decreasing, right? So thing is, this L and R only works. The sliding window only works when we have only positive integers, right? But we don't have any positive integers. So instead of this, when we you see when we have this these type of questions in our exams or interviews, right? Assessments. So when we have given some array and we count the subarray sum to divisible by k or the sum is k, right? And we have to count the subarrays, right? And subarray is the continuous part, right? So we have to think about this also because it is a subarray part. So we have to think in this direction, continuous. So one thing should pop up. One thing should pop up in our mind is the prefix sum, right? Prefix sum. So if I build an array of this as prefix sum, let me see. This is 2, this is 1 here, right? Then 4, right? Then I have 9, then I have 7, right? This is the prefix sum. So to get the sum of these two, this subarray or this subarray or this subarray, right? So to get the sum of subarray, right? I comma j, what I should get is prefix of j minus prefix of I minus 1. You see this because I minus 1 is this I should must be included, but our this I must be included, right? This is the inclusive. That this is why I have to subtract the I minus one part, right? So if I want to get the sum of this uh, this part, right? What I can say is like this subarray, right? What should be the sum of this subarray? 538 minus 1 7, right? 7 should be there. So this is index is 1 2 3. So 1 comma 3 I have to get, right? So what I have to subtract? Prefix of 3 minus prefix of 0. Prefix of 3 is what? 0 1 2 3 9 minus 2. It's 7. So I get the exact sum I was here. I was getting here, right? That's how we can find the subarray sum, right? So how can I find this number of subarrays in this case, right? Yash? Because the target could be negative also, right? So I have this prefix sum subarray, right? And how many subarrays I have, right? How many total subarrays I have? Okay, so there is no fixed size, right? So I can have like many subarrays, like I can have n subarrays, I can have n minus 1, I can have n minus 2, right? Order of n square subarrays I have, right? Possibly, right? Right. So let me try this now. Uh, right. If I am going from here to here, what I should calculate, right? Should I calculate? Then I have to. Should I go here? Then should I go here like this? The and this is similar as this is very similar to the I could have done this here also. There is no sin, right? So how can I optimize it? That's the question. Right. Uh, okay, then how can I like if I go from here to here, here to here, and here to here, right? Then this is then again it's order of n square, right? There is no benefit of it, the qualitative of the prefix. Right. If I count this summary, count this summary, this summary, right? These are different summaries. Then this is also different, this is also different, this is also different, right? Is there any trick given in this? I think sorting and searching. Oh, so the category is very different, right? Sorting and searching. So is this any hint in this sorting and searching, right? Sorting and searching. Now, if I can sort it, let's say, if I sort it here, right? 1, 2, 4, 7, 9, right? And if I want to calculate the answer, then 4 minus 1. Okay. Okay, I can put 0, 1, 0 also. Okay, so 7 minus 0, it's 7. 1 count, okay. 9 minus, okay. Then 9 minus 1, no, 9 minus 2 is 7 also, okay. 9 minus 4, 9 minus 7, it's not coming. So we have two sevens here. All right. We have counted it as if I do sorting. Why this sorting is working? That is also a question, right? Or this just a fluke? I think it's just a fluke here because uh, can is there anything? Right. So right. Should I take any other example? If that works, then we can go for it, right? Okay, let's say if it was 5, right? If it was 5, then how many of them? No, till 5. So no, 5 to 7 minus 2, 3 here, right? No, no, sub-arrays must be like this, continuous, right? So, hmm, how many fiber we can get? 7, no, 7, 9 minus 1, 9 minus 2, 7, 5. No, this is not how we can get, okay. Then we can get between this. Uh, I am getting this in order of square by prefixation trick. Can I optimize it? The prefix sum plus hashmap. Okay, all right, all right. All right, so that was the question. That was a trick also. We have to find that instead of looking back at the balance of every single previous day. Okay, so in the real world of this, okay, in this real in the real world of this problem, imagine you are tracking a company's total financial ledger over time, right? So let we are tracking this like day zero, day one, day two, day three, day four, day five, day six, day seven, day eight, like this. We are tracking the financial ledger, right? Now, your current total balance on day J is your running prefix sum Pj. Yes, we have our running prefix sum Pj of any at any day, right? Here, day zero or like this something anything, right? Let's say we have this prefix sum 21497, right? 21497, right? This is our running prefix sum for the array of this given 2 minus 1, 3, 5 minus 2. 2 minus 1, 3, 5 minus 2, right? Here. And target is 7. Okay. Now, your current total balance on day J is your previous sum, yes. So at any given day, our total balance would be this prefix sum, right? So on, let's say on day one, this two, three. On day three, I have this total balance, right? You want to find how many specific historic periods resulted in a net revenue of exactly yes. You wanted to find how many specific historic periods, not the specific day, periods, right? Resulted in a net revenue of exactly shape X. Okay. So what we can do that this there is a equation, right? That Pj minus P of I minus 1 is equal to X. This is the summation. If I do this, then Pj minus X is equal to P of I minus 1, right? That means uh, that if I get Pj minus X, right, whatever the my prefix sum is, right, whatever my prefix sum is here in this case, and if I subtract this from here, if this value, right, is equal to prefix sum of I minus 1, right, right, then I have encountered, right, encountered the sub-array sum, the target, sub-array target. But the problem here is, guys, that let's say 9 minus 2, it's 7, right? Target is 7. So from this is 0, 1, 2, 3, P3 minus this right, minus P0 is equal to 7 means P3 minus 7 is equal to P0, which is 2. What is P3? Is 9, right? So that is this is correct. But the thing is that I have to, the next thing, guys, is that I have to keep track of how many times I have encountered this this possibility. At like so this 9 minus 7 is 2. That's correct. But how do I know that this I is my uh, like I can go for J, right? But how to choose I in this case? That is the problem, right? How to choose I here? Which I we are talking about? Is this I? Is this I? Is this I? Right? Then again, if we are choosing I and J both, right? If we have to choose both, then it's again order of n square. That's not the correct way to represent that, right? So you see, what we can do is we can take a map, right, like this. We have encountered two, two minus prefix sum is two, right? Two minus x is minus five, right? This is minus five. This has come one time. Uh, one minus seven is minus six. This is come one time. Four minus seven minus three, one time. Nine minus seven, which is two, one time, right? 7 minus 7, which is 0, one time. Okay, so what are we getting from here? I think nothing, right? Or what we can do is like this, right? I don't know, I'm just trying, guys. I will see the solution also, what is that, but we can do less. 0, we have encountered one time, and 2, we have encountered one time. 1 is one time, 4 is one time, 9 is one time, and 7 is one time, right? Now, if I go that 2 minus 7, that's not there. 1, 4, okay. 9 minus 7, 2 is there, right? 1. So I add one time, right? Answer is equal to 1 plus. Now, again, 7 minus 7, 0. This is again 1. Answer is 2, guys. I think that is the only way it should have solved it. X. Then we isolate prefix. But rearranging this equation, we isolate the historic prefix we are looking for. Pi minus 1 is equal to Pj minus 1. Yes, ma'am. This equation is the key to dropping the inner loop. As you iterate through the array, you maintain a hash map that records the frequency of prefix sum you have seen so far. At each step j, you calculate in your new pj, compute the required historic balance pj minus x. Now the hash map actually how many times this balance occurred in the past. Right? On order of here is the ordinary information C++ map, which where the S collision vulnerabilities in unordered map and complete program CSES. Okay, all right. How it is doing it? X prefix 0 is 1. Okay, prefix counts map prefix. This is the prefix sum and count is here. Okay, and prefix count. 0 is 1. Okay. Long prefix sum valid sum varies. Current prefix sum plus is equal to value. Long required current prefix sum required is there. Okay. If it is there, then valid summary plus equal prefix counts summary. Okay. If it is not there, prefix sum current prefix sum plus plus. Okay, so guys, that is the only way I was telling you also. This is the same thing. We have to do this one. Okay, this part. So this is a very interesting question, and let's try this. Now we have to do it. Okay, so what is the question here? Hmm. This was the question, right? Input format. First input. Okay, wait. First we have to get the boilerplate first, right? Hash include use string, and then I think I should need vector also. Vector, and I need some. I think I need this unordered map, right? Unordered map. Just that's it. Use use name space, right? Standard and main here. What is input? First input line has two integers n and x. Size of the array entirely. Okay. So integer n comma x is here, right? C in x. One more thing we can get is the iOS base, right? Sync with a standard IO, which will be false, right? Here, and one thing is scene.py, which will fill null, and now what we can do is we have n and x. We should have a vector, right? Vector of integer array of size n, right? We can initialize it with 0 also, and next n integers okay, so for I equal to 0, I less than 1, I less than yes, right? C in array here, and after that uh, we have this okay, we have the input, right? Now first thing first, what I need is this map first, right? Hash map, which will have prefix sum and their count, right? So unordered map, long comma integer counts. It's like map here, right? And map of zero sum is already we have seen. Let's say assuming one time. That's a very important thing. And again, what I need a prefix vector. No, I just need the variable for this. I think yeah. Long prefixes sum equal to 0 and integer count. Okay. Now what I can do is for int I equal to 0, I less than n, I plus plus, right? And first of the prefix sum I have to go plus is equal to the this array I, right? I have this prefix sum. Now, and one thing I need is one is long required sum, right? or required some required what is required? Okay, required prefix we can say is equal to prefix sum minus x. Right. So if there is map dot find this required prefix is there, right? It's not equal to mp dot end, right? Then in that case, if it is there, right, then count plus is equal to this map dot required prefix, right? And okay, and what we will do is this map comma prefix sum plus plus, right? We have to count that, and after that we can print out the layout this our count, right, like this, and we from 0 after that. I think it should work. What is the input here? Example input was this, right? If I give it to this file and inside it I go for g plus plus main dot cpp or main, and I have this get what is it? Print input.txt here. Answer is 2, right? It's giving answer 2 correctly, and if I change input to this 5, if I go again, answer is again 2. If I go as is 3, then answer what should be the answer? Again 2. Okay, if I change this to 1, then what is the answer? 1 answer. Oh, so it's changing. Yes. 3 minus 2, no, 5 minus 2, 3. Oh, 2 minus 1. Okay. No, it's changing, guys, and if I give it as 8, then what is the answer? It's 1 again. Okay. I think it should work in this case. Let's try to submit it. Choose the file input.txt main.cpp here, like this. One wrong answer, one TLE. Wow, everything is occurred here. Is there anything we have missed in the solution? This is the worth checking, right? Where's our prefix some required history? Okay. Okay, I have to get this long. That is one thing. And long value, C in value. What? Okay, the thing is, this is just a running thing, right? The input is also in this, not like, okay, we don't have to take the vector for array vector, right? Just this map, and then long value, C in value, at place is equal to value here. Okay, We can do that also. Alright. These are little optimizations we can do, guys. Very important here. Right. This for loop we don't require actually. Right. What we need is this for loop, and in this for loop we have this long value and cin value, right? And this is value here, not end. Okay, so count we will do. Count require history, okay only. So I think rest thing is all right. Return zero at the end. Long is also thing. Okay, everything is in long, so no integers. Just count is integer. Hmm. Long value, long prefix if that, and I go for dot count required prefix is there. Okay, fine. And I go. Okay, let me try this again and submit it. Choose a file, mail.cpp, and try to submit again. And one again things get tricky. See here, if I go to this, oh, I don't need this. And I don't need, I think, vector also. Right. It's a very specific story about what's happening under the hood. You hit two distinct traps, incomplete wrong answer, test 7 and 27, LTLE on test 28. Wrong answer, integer overflow. If you translate the logic into your own code, it is almost certain that variable was declared as standard int. In this problem, each element can be up to 10 power 9 if the subarray is filled with positive 10 power 9. The maximum prefix mathematically says and overflows the current sum exceeds this limit. The better wrap up was negative number for now every variable handling is some a target of the line. Okay, log down. The TLE, the hash collision attack, affects the TLE. This is to map a study map which uses the slow login binary search tree. Uses the order one hash table. Okay. Think of hash table as a library where mathematical formula is function determine exactly where map the identity function for integer k equal to k. Platforms like CSS literally run anti-hash test cases like test 28. They feed a program numbers spaced exactly by the hash table bucket size. Okay, so they feed a program numbers spaced exactly by the hash table's bucket size. Okay, this forces the collision where each single sum is assigned to exact same cell. Right, the library in a program forced to search sequentially through thousands of items to creating your order lookup back into an order of square time limit disaster. So we defeat this by injecting a randomized mathematical permutation like split mix 64 algorithm to scramble the key non-deterministically by adding a random time-based seed. It becomes mathematically impossible for a test case to predict where our collision will happen. Ultimate problem solution. Here is a fully optimized character chrono std. Okay, custom has we have to we are finding. Okay, after custom hash we have developed size the operator unity const static count fixed random chrono whatever it is. Here we are doing this again guys. Just a minute. Alright guys, this is how we can develop these things. Let me try to do this also. Hold it. Our code also has include stream, and then we have vector also there, finding include some chrono library they are finding, and map, I think, map or unordered map. Okay, just unordered map, right? Unordered. Okay, then again using now next thing they have done is this: secure the mathematical permutation to defeat a His collision. Right? What is this? We are building a custom His. Okay, struct custom His. Okay, so struct custom His. Right? In this custom His, we have a static unsigned int 64t. Right? Static unsigned int 64t. This is the split mix 64. Okay, split mix 64. U and okay, console into 64 T X. Okay, this is also a function inside it. Okay, okay. In that, bitwise avalanche function to scramble the bits evenly. Okay, so x plus is equal to this something. We have x plus is equal to 0x anything in that. 0x here, right? Plus is equal to then x nor shift x is equal to x nor x shift shift 8 times, okay, into this 0x something here, right? Then we have then again it's 27 times, right? X is equal to x more 27 times into next thing is here. We will understand this, guys. What is this doing? I don't also understand it. That's okay. Then return x, okay, x now x 31, I think, right? Right. Then we have the size t operator. Size t operator, right? And in 64x 64 tx const right. Here incorporate a fixed random seed generated at runtime. Okay, so static const this fixed random, right? Static const 60 40 right. Thing is fixed random is equal to chrono steady clock. Now what is going on? Chrono steady clock now, right? Time since epoch, or time since epoch dot count, right? Then we return the read my 54 x plus fixed random plus fixed random, right? After all of this, we will quietly. This is our custom hash function, right? Then we can have this everything solve custom hash. Okay, we can pass the function also, right? Okay, so where is this just a function? Where is the main? We just solve. Okay, word solve and long x and x, right? And then our map, which will be long first comma int comma custom hash map we are finding here, and right, prefix count dot n pre-allocate space to prevent expensive rehashing. Okay, so map dot reserve and reserve of n size, then prefix count 0 mp dot 0 1 right, long current sum, long surveillance count, right? Long current prefix equal to 0, long count equal to 0 also. For and I equal to 0, I less than I plus plus long value same value, right? Current prefix is plus equal to value, right? Then we will have this target, long target is equal to current prefix minus x, right? If dot count target, then in that case count plus equal to map dot target. Then we have map dot current prefix plus plus. Okay, so I have to go to find, not the count. Okay, so if iterator is not so we count equal to okay, so instead of count I can do this thing. If map dot target find target is not equal to what is this? To map dot end. In that case, what I will do is mp dot target is equal to no count plus equal to m dot target. Very simple thing. And now then prefix count plus plus C out. Okay. C out count and then I have enter mail here as base sync with the extended IO usually false for us, right? And this is in the try is also null. Solve function I am calling and I will return 0. Let me do this thing. Again, giving one answer. What happened? Okay, let me try to submit it directly. Right. Submit to the file and it's accepted. Okay. It was very complex implementation. So can I ask you, do you have any more simple implementation looks very next? Okay, just a simple hash is there, a random XOR k, and we just need a simple hash. Ooh. Well, it's like everything is same here. So we have to find this thing called. Uh, I have to understand this implementation first, right? So I can go to ChatGPT and or I can ask that also. Here only that I don't understand the syntax of this implementation. Move this into this with all technical detail scratch and simple language at syntax and semantic level and how I can implement it and where what is component name and why we require that component and data structure, what are the variations and applications of those cells, show me with other examples. Right.
हम लोगों को ये प्लस पॉइंट रखना है कि भाई उधर मत करवाओ, इन बच्चों को बस छेड़ो। छेड़ना है तो मेन ब्लॉक में जो रहते हैं ना उस साइड, आशीष साइड वाले उनको करो, क्योंकि वहां पे वॉशिंग मशीन है, वहां पे वॉशिंग मशीन है जहाँ बच्चों को क्वारंटाइन करने का। मतलब कपड़े धोने तो हम जाएंगे तो रिस्क बढ़ेगा ना भाई हम लोगों के लिए भी इन्फेक्शन का, वही बच्चे वहां पे रह रहे हैं, तो वो पॉइंट है। अभी नीचे चल रहा है जो शुरू से कर रही है, तो आ जा 2 मिनट, शिफ्टिंग चालू करवा रहे हैं। उठा पटक सुबह से इनको बोल रहे अपना शिफ्ट करो।
ये देखो तो रह रहे हैं ना पर दोगे तो इधर है।
किधर है?
किधर शिफ्ट करवा रहे हैं?
ऊपर
कौन सी बिल्डिंग को?
द्विवेदी वाली बिल्डिंग को
उसको उसमें वॉशिंग मशीन थोड़ी है वहाँ पे।
है ना, वॉशिंग मशीन के वहीं तो है, ई ब्लॉक के वहां पे है उसका।
आशीष है वॉशिंग मशीन का।
आशीष साइड आ, तो बता रहा हूँ चलना। 2 मिनट का काम है, नदीम से बोलेंगे वो उनको रोक के उधर कराएगा। लेट कर दे तो बच्चे शिफ्ट करने चालू कर देंगे। अभी फोन आया देवी जी का, सूख नहीं उठा हुआ तो
यार वो मानेगा ही नहीं करना।
कोशिश तो करते हैं।
नहीं कल वो बात अलग है, वो नहीं मानेगा।
हाँ बट लेजिट रीजन है ना यार, हमारे कपड़े धोने के लिए फिर एक ही बूटी ब्लॉक की वॉशिंग मशीन
तो
करेगा,
कपड़े धोने घर से चले जाओ, कह देगा वो
पूरी भीड़ होगी। हाँ
कपड़े धोने घर से चले जाओ, बोल देंगे।
तो ये ब्लॉक में भी तो केसेस है,
हैं?
ये ब्लॉक में भी तो केसेस है,
तो फिर क्वारंटाइन करूंगा तो ऐसे केसेस तो नहीं।
तो इसलिए तो बोल रहा हूँ।
वो कहेगा ना,
वो
उसको
वाली
बंद
जो आशीष वाला बेल्ट है उन लोगों को ऊपर शिफ्ट करा दो, क्योंकि अभी जो शिफ्ट कराया उन्होंने, जो सामने फ्रंट फेसिंग वाला बेल्ट था कार्ड के पीछे वाला, रूम नंबर 1 से लेके 11, समझ गया ना, जो इधर फ्रंट फेसिंग था गार्ड की जस्ट पीछे जा कार्ड बेल्ट था, उनको करवाया है।
मुझे नहीं देख सकता बार बार फरमाइशी करना सही नहीं है। ठीक है हर चीज में हम तो तुमको प्रॉब्लम।
जो सारे नेता है तो
अरे तो नेता है तो इसका मतलब ये थोड़ी है तो बार बार जो काम है वो भी जाओ, नहीं काम है वो भी जाओ। एक बात बता, वो बोल देगा इधर के बस, अगर तुमको परेशानी हो रही है सिर्फ टोटल तो उनको नहीं होगी क्या? तो उससे
परेशानी
तो हो
वाली
गया।
बात नहीं ना, परेशानी
तो
हम लोगों को है क्योंकि वहाँ वॉशिंग मशीन है, ऐसा परेशानी हम लोगों को है, उसको तो शिफ्टिंग कराना है,
तो
परेशानी
वॉशिंग
हमें
मशीन
क्यों?
इधर दूसरे उससे चले जाओ वॉशिंग मशीन के पास।
मतलब
एक ही रास्ता वॉशिंग मशीन के पास जाने के लिए।
दूसरा रास्ता ई ब्लॉक के अंदर से होके जाने का, ई ब्लॉक के अंदर भी तो केसेस है, फिर वहां होकर जाने का क्या मतलब है?
तो वो तो क्वारंटीन हो जाएंगे ना भाई।
तो भाई निकलेंगे तो बाहर टॉयलेट तो यूज करेंगे
तो
कॉरिडोर
क्या
में।
हवा में बैरर घूम रहा है क्या?
हाँ
है?
हाँ,
हवा में नहीं।
अबे हवा में है, ये हवा और कांटेक्ट दोनों में है।
अरे यार वही बात है उसको।
इन चूतियों ने सोचा ही ना करने से पहले, एक चक्कर लगा के आते चलना, समझ रहे? 5 मिनट का काम है, मैं भी तो चल रहा हूँ।
अरे
मैं बोल दूंगा तो बस चल दे।
पहले रुक जाता हूँ, सोच नहीं रही थी। वो नहीं मानेंगे, कोई सवाल नहीं।
तो मैं उसको मनाने का बोल भी नहीं रहा हूँ, कोशिश करने का बोल रहा हूँ। उसको मनाने का बोल भी नहीं रहा हूँ, कोशिश करने का बोल रहा हूँ, तभी मान जाए, बस मशीन का सोचते। उसको तो शिफ्ट कराना है बच्चों को, उसको 12 रूम खाली चाहिए, उस साइड के 12 खाली करा दे जहाँ मशीन नहीं है, जहाँ आशीष रहता है, समझ रहे हो उधर। उसको तो बस शिफ्टिंग से मतलब है। क्योंकि हम तो मशीन यूज करते हैं ना, हम लोग तो मशीन यूज करते हैं ना, हमें वहां जाना पड़ता है। अब यदि ये वहां पे कर देगा बच्चों को क्वारंटीन, उस एरिया में जाना ही मना हो जाता है, जैसे वहाँ मलागर वगैरह चिकन पॉक्स वाले, तो वहां गाड़ी नहीं जाने देता है तुम्हें, और तुम खुद भी नहीं चाहते, क्योंकि तुम्हें भी डर लगता है भाई, और बीमार बच्चे पड़े हैं बच्चों वहां जाने का। तो कपड़े धोने के लिए सिर्फ वो एक डी ब्लॉक वाला एरिया बचेगा, सबके सबकी भीड़ भाड़ पड़ेगी, मशीन खाली नहीं मिलेगी। तो करो काम, काम करने में नहीं, थोड़ा बाकी बच्चों का भी सोचो जो कि नॉन इन्फेक्टेड है, कि भाई तुम उस एरिया को करोगे तो मशीन हमारी छूटेगी। हमें कोई ऐसी ऑटो दिक्कत नहीं है, रिक्वेस्ट करनी है बस। ज्यादा लेट करेंगे ना, वो बोलेगा कि वो बच्चे को शिफ्ट करना शुरू कर देंगे। चल चल चल। कहते हैं जुकाम हो गया है।